Banking of roads 01. Objective: to understand the role of friction at circular turnings and banked roads. Maximum allowed speed while taking a turn. When a car takes a turn, each curvilinear section of the turn can be approximated to be an arc of a circle with a certain radius. A centripetal force must act towards the center of the arc to enable the vehicle to move along it. This centripetal force is provided by the static friction of the surface the car is moving on. The normal force N balances the weight of the car mg. If the coefficient of static friction is mu, the maximum frictional force which can act towards the center of the arc is mu mg. While making a turn, if the velocity of the car is v and radius of the arc is r, the centripetal force acting on it would be equal to mv square by r. For the car to make a safe turn, the required centripetal force should be within the limit of static friction, which implies that the velocity of the car should be such that it satisfies the relation mv square by r is less than or equal to mu mg. In other words, v should be less than or equal to the limiting value root over mu rg. If the car moves with a velocity greater than the limiting value, it skids away from the center. Banking of roads. We cannot always rely on friction as it depends on external factors such as rain or frost, which significantly decreases the value of static friction. To avoid skidding of vehicles at turns, the outer edge of the road is raised up, which is called banking. Suppose surface of the road at a turn makes an angle theta with the horizontal surface. This results in the horizontal component of normal force, n sine theta, acting towards center, providing the necessary centripetal force at the turn. Friction is not taken into consideration here. Therefore, n sine theta is equal to mv square by r. The vertical component of the normal force balances the weight of the vehicle. So, n cos theta is equal to mg. From these equations, we arrive at the equation tan theta equals to v square by rg. Thus, v is equal to root over rg tan theta. This equation gives the speed which, in the absence of friction for a given angle of inclination and radius of curvature, would ensure that the vehicle remains in its designated path. This is known as the rated speed or balancing speed of a turn. Rated speed of a curve does not depend on the mass of the object. Summary: the maximum speed with which a vehicle can move without skidding while taking a turn on a horizontal road is root over mu rg. The maximum speed with which a vehicle can move without skidding while taking a turn on a banked road is root over rg tan theta.